Welcome. Mathematics 6th Standard Part 1 Basic Geometrical Ideas 4.9 Polygons Part 7 Polygons. Look at these figures. 1, 2, 3, 4, 5, 6. All these are closed figures. But these are not random figures. These are joined with the lines here. Straight lines. Curved lines. They have a particular shape here. What can you say? Are they closed? Yes, they are closed. How does each one of them differ from the other? They are special because they are made up entirely of the line segments. One of these are also simple closed curves. They are called the polygons. So a figure is a polygon if it is simple closed figure made up entirely of the line segments. Draw 10 differently shaped polygons. What are called the polygons? I'll tell you. See, simple polygon is, this is a triangle, it is polygon, and with four sides it is also polygon. Then with five sides it is polygon. With six sides it is polygon. Like this, the closed figures with line segments, those are called the polygons. Do this, try to form a polygon with five matchsticks. It is a five matchsticks example. 1, 2, 3, 4, 5. Okay, four matchsticks. With four matchsticks we can join like this, one more polygon, and three matchsticks. This becomes the shape polygon, and two matchsticks. What can you do with two matchsticks? It is not closed, it is open. Okay, in which case is not possible? Why? This is not possible. This is not possible. With two matchsticks you cannot form the polygon because it will not become the closed shape there. Therefore, it is not a polygon. Sides and vertices and diagonals. Okay. Example, examine the figure given here 4.14. Give the justification to call it polygon. 4.14 here it is. This is now backward. This figure ABCDX, it is polygon, it is closed and it is made up of the line segments. Okay. Therefore, the line segments forming the polygon are called its sides. What are the sides of the polygon ABCD? If the figure is not here, I will do this figure 1, 3, 4, 5. A, B, C, D, E. Okay, up to E it is. Note how corners are named in order. A, B, B, C. This is A, B. This is B, C, C, D, D, E, E, A. These are the sides of the polygon. The meeting point of the face is called the vertex. These are the vertices. A, B, C, D, E. Both points. These points are called the vertices of the polygon. The sides A, E and ED meet at E. AE and ED meet at this point E. E is a vertex of the polygon A, B, C, D, E. Point B and C are its other vertices. Can you name sides that meet at these points? Okay. See, at the point B, which are the sides that meeting with this point? AB, BC are the sides. Those are meeting this vertex. Vertex at the C, BC and CD are meeting. At the vertex D, CD and EEDE sides are meeting like this. Can you name other vertices of the above polygon ABCDE? Other vertices. What are the other vertices are there? Only 5 are there. Any two sides with a common endpoint are called the adjacent sides. Okay, this is a vertex. The sides meeting at this point ED, ED and EA are adjacent sides. These are adjacent to each other meeting at this point, and these two ED and DC are adjacent sides. DC and CB are adjacent sides, and BC and BA are adjacent sides. The endpoints of the same side of the polygon are called the adjacent vertices. Okay, this is a side. ED is a side. Okay, E and D points are vertices of this side, adjacent vertices of the side ED. Suppose DC is a side. For this side, two vertices it has. Those two are called the adjacent vertices D and C. Okay. Consider the pair of the vertices which are not adjacent. The joins of these vertices are called the diagonals of the polygon. Diagonals. These are diagonals. These EC is a diagonal. DB is diagonal. AD is diagonal. AC is diagonal. Okay. In the figure, AC, AD and DB, DA, these are all diagonals. Is BC diagonal? BC is a side. It is not diagonal. It is a side. Why? Why not? Because it is the closing point of this polygon. The sides making this polygon are called the sides, not the vertices, not the diagonals. Okay. If you try to join the adjacent vertices, will the result be a diagonal? No, adjacent vertices, joining adjacent vertices makes the side, not the diagonal. Name all the sides, adjacent vertices of the figure ABCDE 4.15. These are the adjacent vertices of ED. ED is E and D. D, C are adjacent vertices of the side DC. Okay, DC. Then BC. BC side adjacent vertices are B and C. These 2 points. AB sides adjacent vertices are A and B. EA side adjacent vertices are E and A. Then, now let's name the adjacent sides. The meeting at the common point, those two sides are called the adjacent sides. EA, AB are adjacent sides. BC, BA are adjacent sides. DC, CB are adjacent sides. DE, DC are adjacent sides. Okay. Then diagonals are these all: AD, DB, EB, EC, AC, AD. All these are diagonals. We have named all these. Draw polygon A, B, C, D, E, F, G, H and name all the sides, adjacent sides and vertices as well as diagonals of the polygon. How many vertices are there? 8 are there. A, B, C, D, E, F, G, H. Okay, these are all vertices. Joining these two adjacent vertices makes the side of the polygon. Like this I draw. It should become closed with the help of the line segments. These line segments are called the sides of the polygon. Okay, now I have to name all the sides here. AH, HG. Now let me name like this. Okay, clockwise order. A, B, B, C, C, D, then D, E, E, F, E, F, G, H, E, F, G, H, H, A, H, A. These are all the sides of this polygon. Then adjacent sides. Adjacent sides are these, meeting at the common point. For the point A, what are the adjacent sides? A, B, A, H. A, B, A, H are the adjacent sides. For the point B, what are adjacent sides? B, A and B, C. Okay. Then at point C, C, A and C, D. At point E, here, at point E, what are adjacent sides? ED and EF. These are adjacent sides. And like this only, adjacent sides over vertices. Or what are the vertices? All these points. A, B, C, D, E, F, G, H. All these are vertices. 8 vertices. The points are called the vertices as well as the diagonals of the polygon. These are diagonals. This is diagonal and this is diagonal. This is diagonal. This is adjacent side. This is diagonal. This is diagonal. Okay, from this point again to all this becomes diagonal. This becomes diagonal, this becomes diagonal, this is diagonal. Okay, again you take one more point. This is, it become complex. Okay, please subscribe my channel, hit the bell icon and save the playlist. Thank you very much. Bye bye.